Hello everyone. Today we are going to discuss about an example ADT to implement stack operations. Now before we see what stack what are operations of stack, we'll be going to see about what is a stack. So the formal definition of a stack is a data structure that stores some number of data elements and only allows access to the data element at one of its end, which is top. Now look at this. Now only one end we told, and that is a stack. Now this is called as a stack. It is a data structure where we will access the data elements. Now the stack is empty. So this is empty, no element is there inside. So if I wanted to place any element inside of the stack, then I will be inserting the element from the top position, that is this position. So now I am inserting the element into the stack. This insertion element is called as push. Okay. Now creating the stack is called as creation. So let us assume that I'm pushing some element, that I'm inserting some element into the stack. So when pushing is performed, when top is not equal to maximum size. Let us take the example that stack size is 5. Okay. The stack maximum size is 5. If top is the only place through which we will place the element, now top is equal to once it will be 5. When top is equal to maximum size, then we cannot insert the element. Correct? Now I am taking maximum size is equal to 5, and once in the operations top value will be hit to 5. When both are equal, push cannot be done. What is push? Inserting the element. If I define the size is 5, I cannot push the element when top is equal to 5. Now top is equal to minus 1. Assume that top is equal to minus 1. Means what? Stack is empty. When top value is minus 1, stack is empty. When top value is maximum size, then stack is overflow or stack is full. When top is equal to maximum size, stack is full. When top equal to minus 1, stack is empty. Now this is what the stack, as it is having only one end. So now top equal to minus 1, which is empty. Now I am performing push operation, which is inserting the element into the stack. Now I am inserting the element. Assume that the element is 1. And still stack top size equal to not 5. It is one position, top 1 position, and top 2 position. I inserted 2 element and 3 element. I have given these elements into the stack. That means I pushed these 3 elements into the stack. Okay. Now three element is I have pushed just now, that is last in. Among these 3, which element is last inside? 3 element is last in. Which element will be taken out first? 3 element is taken out first, and that is what stack is called as LIFO order, last in first out. And this is about the stack. What operations basically stack performs is creating stack, push element into the stack, pop element from the stack, stack is empty or not, what is the element of top. These are what possible operations what we will perform using stack. Now these are what stack ADT. Stack ADT is what? Create stack. Now what is the description? Creates and possibly initializes a stack object. Destroy stack is what? Will deallocate the storage for the stack. When you are initializing a stack object, memory is created. Destroy stack is what? Will deallocate the memory which is created this object. we created memory for this object that will get deallocated using destroy. Now what is empty stack? We will be predicating that it returns true if the specified stack is empty and false when it is not empty. Push stack comma element is what? This is my object to which stack I am pushing the element. This is what my element, what I wanted to push. Pushes the specified element on the stack. Pop stack is what? Removes the top element from the stack. So this also you have to keep in mind. Always top element will get deleted. So for that we need not to give what element we have to pop. Push is what? We can specify what element to be inserted. Pop is what? Anyhow you cannot choose any either item to delete, only the top. So pop stack means what? Whichever top indicates, that element will get deleted. Top stack is what? It returns a copy of the element from the specified stack. Note that some implementation of ADTs do not require the create and destroy operations. So when you implement Stack ADT respective to other programming languages, there is no guarantee that every programming language will take create and destroy operation. But all the programming languages, wherever you are implementing Stack ADT, that all will take push, pop, empty, top. These are what mandatory functions what you can see, but all languages will not support create and destroy operations. Okay, example, simply defining a variable to be of an abstract data type may implicitly create the underlying data structure and initialize it. There are languages which takes implicit creation of the stack. The storage for such a variable may be implicitly deallocated. So creating a stack will be implicitly created. Deallocation also implicitly done. So there are languages which will do. But it is sure that stack will perform these four operations in all the languages. A client of the stack type could have a code sequence such as the following. Now, create stk1. This is what? Object of the stack. Push stack1. Name of the stack which you wanted to use to insert the element. Color1. Maybe spelling wrong. Okay. Color1. Temp is equal to top of stack1. It gives the top element of the stack. It tells the inserting element is color into the stack, and it tells the object of the stack. So this is what the example of Stack ADT. The reason why I am calling these are Stack ADTs, or just now we were discussed about these, right? These are Stack ADTs because you can see what operation it performs. You can see what function name, what it performs, and what is the object of it, but you don't know how it is implemented. Look at all the functions, look at all the process. All these are ADTs. Why? Because specification part is viewable or visible, or it is given access to take, but implementation is hidden. Hence this is an example of Stack ADT. Thank you all.